Hello, my name is Abby, and my partners for this project were Michael and Ty, and today we will be talking about our project, which is about UFood Grill and the wait times. DMAIC stands for Define, Measure, Analyze, Improve, and Control. For our project, we will define the problem, which is the wait times at UFood Grill. We will measure the time it takes for the customer to get through the line and to receive their food, as well as what the customer ordered. We will analyze those measurements and see where the bottlenecks are and how they can be improved. We will look at some solutions to improve the wait times, which might be hiring another person or having a certain amount of food prepped before the rushes start. Lastly, we will control our improvements and see how well they are doing by doing more time studies and asking the workers how they feel about the changes and if they feel it has improved or not. We have been collecting data over the past 2 months. On Tuesdays and Thursdays, we collect data from 11 to 11:30, and on Monday, Wednesday, and Friday, we collect data from 11:30 to 12. We wanted to try and capture when UFood is at their busiest, so either when they open or right after convocation. In the beginning, we would ask people what they ordered, but then we noticed that we could look at the register instead of asking people, so this made the process a lot easier. For the time study, we had about 3 stopwatches going to try and collect enough data. We would pick someone just walking into the line and start the timer. Once they got their receipt, we would hit the lap button, and once they received their food, we stopped the timer altogether. To track our data, we used Excel and then we used JUMP to analyze the data.
Next, we'll move on to the hypothesis testing portion. And in this part, we'll cover the student t-test, the mean and variance charts, the chi-square tests, and the design of experiments. So first off, we have 2 student t-tests. The first one is the wait time on Tuesday, Thursday, which is sample 1, versus Monday, Wednesday, Friday, which is sample 2, to get their receipt. And we can see that we have 33 as our sample size for sample 1 and 25 as the sample size for sample 2. And with the data that we took, we have the test results here with the p-value of 0.0133, which is less than 0.05 significance level. So we will reject the null hypothesis and conclude that there are differences between the wait time of sample 1 and sample 2. For our second test, we're comparing the wait time to get their food instead of their receipt on the sample 1 Tuesday, Thursday versus sample 2 Monday, Wednesday, Friday. And the sample size stays the same, and we got the p-value of 0.6549, which is much higher than 0.05. So we fail to reject the null hypothesis, and we conclude that the wait time between Tuesday, Thursday, and Monday, Wednesday, Friday to get their food is not significantly different. Moving on to the control charts part of this portion. First, we have the range chart of the time to get received of 2 days, which are March 8th and March 9th. And as you can see, on March 8th, there are 2 points that are out of control, and all the data points of March 9th is in control. And another interesting things to consider is the average of March 8th is much higher than March 9th, which can tell us that the March 8th was a very busy day with the long variation in wait time. The second R chart is the time to get food between the same 2 days, March 8th and March 9th. And on March 8th, all data points are in control, while on March 9th, 1 data point are out of control. And as we can see with the average, it follows what we talk about with the time to get receipt. The average of March 8th is still much higher than March 9th, which indicates March 8th was a busier day. Next, we'll talk about the X-bar chart to get the receipt on March 8th and March 9th, and all the data points are in control, but the average of March 8th is still much higher than March 9th. On the other hand, we see that March 8th has 2 data points that are higher than the upper control limit of the X-bar chart with the time to get food. while all the data points are in control for March 9th. And the average, even though the average of March 8th is still higher than the average of March 9th, the difference are not as big as the one we talked before. For the final control chart, we have the P charts of getting receipt, and on top it's Monday, Wednesday, Friday, and the bottom is Tuesday, Thursday. And the same with the time to get food, on top Monday, Wednesday, Friday, and on the bottom Tuesday, Thursday. Moving on to the chi-square test. First, we have the type of food ordered by PlusSwipe. So the 4 categories for the type of food are burgers, chicken, others, and smoothie. For PlusSwipe, it's whether the student used the PlusSwipe or not, so yes or no. And we got our results, and the probability, the p-value is less than 0.001, which is less than 0.05. So we can conclude that there is a significant difference in the probability of purchasing a type of food with using the PlusSwipe or not. And we can see the same with the chi-square test for the Tuesday, Thursday, as the p-value is still less than 0.001, and we can conclude the same as Monday, Wednesday, Friday. For the next chi-square test, we have the swipes versus smoothie of Monday, Wednesday, Friday, and we have yes or no for using PlusSwipe and getting smoothie or not. And our results, the p-value is 0.2082, which is larger than 0.05. So we cannot conclude that there's a significant difference in the probability of getting a smoothie for students who use a PlusSwipe or not. And again, our results are consistent with the Tuesday, Thursday data, as the p-value is 0.2722, and we can conclude the same as Monday, Wednesday, Friday. Finally, we have the swipes versus day, Monday, Wednesday, Friday, and as you can see, with the probability of chi-square is 0.9295, which strongly indicates that there's no difference between swipe and on each day, Monday, Wednesday, Friday, which we can see by the graphs. And again, we can see that the Tuesday, Thursday is no difference with the graph and the p-value. Moving on to the final portion of this section, we'll be looking at design of experiments, and the first experiments is going to be the time to get receipt, and that is going to be the response. So you can see here the time to get receipt, and the goal is to minimize it. And we have 3 factors, 2 continuous and 1 categorical. The 2 continuous factors are swipes ordered and registers open, and there are 2 values for both for each, 16 and 24 for swipes ordered, and 1 or 2 for registers open. Our categorical factor is line format, and the 2 possible value is against the wall or free flow. And you can see here the model with all the factors and the level 2. And here you see the data table with the randomized factors for each case, the swipe ordered, register open, line format, and the space to get the value on the time to get receipt. Our other design of experiments is the time to get food, and again the response is the time to get food, and the goal is to minimize it. And this time we have 5 factors, all are continuous. The first factor is workers, and we have either 5 workers or 7 workers. Burgers prepared, 4 or 6 burgers. chicken sandwich prepared 2 or 4, smoothies ordered 4 or 8, and smoothie prepared 6 or 10. And again, this is the model with all the factors and the different interactions between factors. And here's our data set with randomized factor values and the space to get the data value of the time. Let's take a look at the value stream mapping for the getting the food out to the customer process. So it started at the supplier, and the supplier would deliver weekly to UFood. And then after that, we have the insertion and then storing of the food. And then after that, we will prepare the food and cook the food. And then we would deliver that to the customer, which is 200, 300 per day. Also, we can see the information flow between the entities, like the weekly orders, and then we have the weekly schedule of insertion and storing food, and the daily schedule of preparing the food and cooking the food. And finally, we have the data with the cycle time, the changeover time, the uptime of the uptime, basically the utilization of each section, and finally the qualification rate.
For our attribute acceptance plan, we will use a P-chart. We will take 22 samples from our time to receive food within a rush time. Rush times are the times between classes, or the time between convocation and the next set of classes. We will say that 20 out of 22 of our samples will need to be less than 2 minutes, which is our acceptance level of time. In order for us to accept this and not change the way the customers are served and food is served, this means that our number of defective samples can be either 2, 1, or 0 in order to accept the lot. This gives us an alpha of 0.09, which means our probability of accepting a lot that does not meet the standards is 9%. For our variable acceptance sampling plan, we are using the average time for the process in an X-bar chart. We will select 20 samples, but we'll use them as continuous variables instead. So instead of setting it to check for either conforming or non-conforming, we'll use continuous variables. This allows us to see how close the times over the 2 minutes are to the average. This also means that times of 2 minutes and 1 second are not necessarily rejected, giving us a little more leeway in terms of specifications. Our plan will be to ensure that our mean for acceptance is 2 minutes or less, and we will take 5 sets of 5 samples during different peak hours. And we'll also need to ensure that we have a low standard deviation. The lower the better, obviously, because we don't want too much variation in our sampling. This shows how our samples perform over time instead of just showing whether they're conforming to our 2 minute set mark or not. This is our operating characteristic curve. This curve is a graphical representation of the probability of incorrectly accepting a batch based on the sampling plan and saying that our process is satisfactory when it is really not. This has to do with our attribute acceptance plan that we talked about before.
Thank you for watching our video.